Okay, so my name is Matic. You may or may not know me. I work at D-Labs, where I hack on Ember and Rails, and I also work at Kundi, where I hack on Backbone and Rails. So I came here to present and talk about Ruby and background libraries in Ruby. So let's just start with this. My motivation for this talk was that I was working on a pet project of mine called SiteStalker, and that I was basically doing lots of asynchronous website scraping. That's what cool kids are doing nowadays. So I was at first using Rescue, which is a Ruby processing library, background processing library, which actually drained my server resources pretty quickly. I'm not sure why I used Rescue. I guess it was first hit on Google at that time, probably, or something like that. And my very poor server only had like 1 gig of RAM, and I had to do like 20,000 scrapings per day. So for that I needed like 6 worker instances and processes, which was like too much for the system and was like an overkill. You have a link of this benchmark framework or something like that if anyone is interested in this. So the big 3 players in this field are Delayed Job, Rescue, and Sidekick. For those who don't know, maybe if someone is new to Ruby, these libraries are commonly used to do stuff without delays in your controller requests, like sending out emails, refreshing cache, sending out various notifications, doing various background calculations without affecting the speed of your server or app. So the first one is Delayed Job. This one is single-threaded. And for each additional level of concurrency, a new worker process is needed. So that implies a big memory resource consumption. And it's really simple to configure with active records. And I also think it's actually tied to active record, which is basically just asking for trouble. Like, and we even shouldn't like store jobs in a database because databases are not meant for that. That might cause bad performance and scalability issues. So single-threaded means if we want to perform 2 jobs at the same time, we need 2 processes, which means basically 2 times of the amount of the memory consumption here. The next one is Rescue, which I'm not sure if it's a bit more popular than Delayed Job or not, but nonetheless, it's single-threaded as well. It's very similar to Delayed Job and also has a big memory footprint for multiple workers. But the key difference here is that it uses Redis. If somebody doesn't know what Redis is, that's a very popular key value store. It's like a Snapchat of databases. It's a far better and faster alternative as a queue compared to a database. So this is how a Rescue web interface looks like. It's pretty slick. You can see what's happening with your workers, which ones are failed, what queues you're having, and so on. So the next big player in this field is Sidekick, which I guess is the most popular one. It's a single process, but it is multi-threaded. But if we run this in the default Ruby's interpreter, MRI, we may end up with some issues because MRI has a global interpreter lock, so there is no true parallelism. More about that later. It's very lightweight, it uses Redis, but the bad thing here is that workers must be thread safe. And that means thread safe code is a piece of code that will work even if many threads are executing it simultaneously. Okay, so some more words about GIL, Global Interpreter Lock. This is a mechanism built into MRI to ensure that two threads belonging to the same Ruby process can never execute simultaneously. This is how a Sidekick web interface looks like. It's also pretty. Yeah. So my hypothesis with my benchmarks was this. For simple and input-output jobs, Sidekick should probably win because it's lightweight, it drains less memory, and not a lot of processing power is needed here. And for really CPU-heavy jobs, like very hard computations, very hard Fibonacci calculations, delay job and rescue should probably win because they can utilize all CPU cores with multiple process workers. So I've came up with this super scientific benchmark, which was made on this exact computer, and yeah, it was like amateurish benchmark. So this thing has 4 cores and 8 gigs of RAM. So yeah, I've came up with 2,000 simple jobs. I've named them simple jobs, which didn't even do anything, just inserted some stuff into a database, and 200 CPU heavy jobs where I was doing some high-cost hashing algorithm. And this line of code usually takes like 3 seconds on an average computer, 3 seconds. So the next batch of jobs was input-output jobs, which was actually just scraping a really slow website. I've made benchmarks for 1, 6, and 12 workers with each of the processing libraries. I measured average processing times, I've measured total times, and I also measured some memory and CPU consumptions. And another note, when I will refer to a number of workers, this will mean the number of processes in rescue and delay job and number of threads for Sidekick. Okay, so let's just mention this quickly. Rails, since 4.2, comes with this really awesome thing called active job, which is a background processing agnostic worker class. This means you can write your workers and jobs in such a way, and you don't even need to know if you're going to use Sidekick or rescue or I don't know what else. So you just write your stuff in this perform method, and then you go to your application config, and you just switch whether you would like to use Sidekick or rescue or other stuff. And then you just enqueue it, and it's working. Okay, so the first benchmark here was simple jobs. I've measured this batch with 1, 6, and 12 workers for each of the processing library. As we predicted, Sidekick wins here because it has less time, takes less time to complete, as it apparently has superior queuing management because jobs are not even doing anything here, just inserting some stuff into a database. So let's move on to CPU heavy jobs when the CPU utilization was really hard. And we can see Sidekick is a big loser here. It takes a lot of time to process this batch of jobs. And we will see in the next slide why that happens. So this is the CPU and memory footprint with rescue and Sidekick. I left out delay job because rescue is really similar to delay job and even a bit better, so I didn't even bother with it. we can see that rescue can utilize all CPU cores, all 4 cores, while sidekick cannot, because it has a global interpreter lock, as I said earlier. So while rescue can work hard, utilize every available CPU core, sidekick is just like kind of wasting CPU cycles while context switching between so-called threads. Okay, so the next batch is input-output jobs, where sidekick is a bit better than rescue. This is where big computational power is not needed. And this is usually the case with input-output jobs, so sidekick apparently is better with this. So this is the benchmark for input-output jobs. We can see that sidekick uses less memory while also being faster. So this is a complete win in this case. So observations here. Sidekick wins for simple input-output jobs and consumes less memory while also performing faster. And at the same time is a very big loser for CPU-heavy jobs for big calculations. It's not so fast. What can we do to minimize the differences here? Maybe we can use this. Does anyone know about this? Has anyone used JRuby before? Okay, great. Really awesome. Okay, so what JRuby is a Java implementation of Ruby that allows running on real native threads in a Java virtual machine. It eliminates the Ruby's great weakness I talked about before, which is the global interpreter lock, where threads only run one at a time and MRI just switches between them and wastes CPU cycles and gives them just a small window of processing time. So now shit just got real. After we switch to JRuby, we can see sidekick performs faster even for CPU heavy jobs. And that's it. And it's faster than rescue, of course. Unfortunately, I didn't manage to get delayed job working on JRuby for some reason, but I didn't even bother, so it's not so important here. Now, look at how well Sidekick can now utilize CPU cores, because it uses native threads on JRuby, so now this is true parallelism. And also look at how much smaller the memory footprint is, which is a total win right now. Let's move on to input-output jobs. We can see Sidekick is also faster here, as we predicted. Again, here is much lower memory consumption for Sidekick, rather than Rescue that uses a lot of processes. So the verdict here is that Sidekick is really weak for CPU-heavy calculations, but on average it wins for everything else. But after switching to JRuby, Sidekick begins to outperform other libraries in general for every type of job, while even using less memory, which is what we wanted to achieve. But in some cases, Rescue still is a bit faster than Sidekick, but its substantially higher memory footprint doesn't justify the shorter processing times. And the final verdict here is, for your average apps, for average jobs, just use Sidekick, and if you have something like heavy, big calculations, just switch over to JRuby and receive extra JVM performance boost, and you also get a bit better memory garbage collection and some other goodies. But like with all things, the selection of libraries is a trade-off of numerous variables. So I guess my point here was to present the differences between process-based workers and multi-thread-based workers and how to eliminate the differences between them. So that's basically it. I would also love to perform this experiment on a stronger machine where I guess differences would be even more significant. That's it.
Did you encounter any troubles yourself with your code not being thread safe?
Not really, because you're watching my mail, aren't you? I didn't because, I don't know, I guess you need to really make an effort to make thread unsafe code in Ruby, I guess. If you're following your Ruby standards coding, like using instance variables, do you have any experience? Yeah.
Especially class instance variables.
Yeah.
Not thread safe.
Do you have any experience with that?
Oh yeah.
Okay. How did it bite you in the ass?
Oh yeah. But it's not for live stream. I'll
Okay.
tell you later.
Is that what happened to your hair?
Yeah. I usually have long hair. Anyway, yeah. Did you try to utilize Sidekick on multiple queues? Because you can specify Sidekick to run on multiple queues and then it runs each queue on a different CPU?
No, I didn't, but that would be very interesting to try. I also read about Sidekick Pro, which is a paid thing. You need to pay for it. But it has this processing in batches stuff, and it's really interesting to take a look at it. Anything else?
Maybe just one here. So when you use JRuby,
Yeah.
was there like a memory penalty from JVM, compared to MRI? Like, did you have to, for example, reserve more memory for JVM alone?
It's true that JVM on average takes a bit more of memory, but on the long run it pays off because it has a better memory collection, garbage collection stuff, and it's also worse because it has a substantially larger startup time for your apps to sync into the JVM. Sorry?
Maybe this is like not directly related to background jobs, but nowadays, like, what would be the cons of using JRuby over MRI?
The cons.
Why not, for example, just deploy everything to a Java application server and just run everything in JVM?
Well, if you have a strong server with a lot of memory, I guess it pays off to, in any case, to run on JRuby. But if you have a weak server and you care about your startup times for workers, then I guess you should just stick to MRI.
Anyone else?
Would it make sense to run your server with Ruby and background processing on JRuby, or is this complicated too much? Because the last time I was playing with both, I hated that JRuby, I don't know, running tests were taking so much more time than just MRI. Yeah, this was good. So I was like, I tried to do development on MRI and maybe production on JRuby, but this was
Yeah, this is exactly what people in practice do. They develop on MRI and then they deploy it to the JRuby stuff. Also running tests. Yeah.
Do I remember correctly that Jan developed something similar to ŽIVO? Yeah, similar to what the string for JRuby. It's called the in or something. I don't know. Yeah. So maybe you can use that. You can start time.
True, he's right.
Okay, thank you, Matic.